Open your banking app's permission lists sometime and read what's sitting there. Camera, location, contacts, phone state, sometimes notification access too. Most people tap allow once during setup and never think about it again. A reasonable response to a dialog box popping up when you're just checking whether your paycheck cleared. But it's worth understanding what's happening underneath, because a banking app is one of the only things on your phone trying to stop fraud and running the same SDK stack you'd find bundled into a free mobile game. I run the privacywired.com, where I spend most of my time pulling apart what apps actually do with the access they ask for, not what the marketing page claims. I've gone through banking app permission flows on Android and iOS, read SDK disclosures where developers bother listing them, and talk to people who work in fraud and risk at financial institutions. None of this is a leak or a scandal. It's just how these apps get built, and almost nobody explains it in plain language. Open libertancy, istana benescent enda mortis. Neither half is a conspiracy on its own. Fraud detection needs signal, and banks have concrete incentives to collect it. Chargebacks cost real money. Regulators find weak controls, and account takeover losses come out of their bottom line. So when a banking app asks for something, there's almost always a legitimate security reason behind the request. The catch is that we need this to catch fraud, and we're also handing pieces of this data to analytics and marketing vendors aren't mutually exclusive, and the app never tells you which request belongs to which goal. Before your banking app asks for a single permission, it's already quietly building a profile of the device you're holding. This isn't hidden or exotic, it's standard mobile engineering. It looks at your OS version, screen resolution, time zone, battery state, the fonts on your phone, the sensors available, and whether the device shows any sign of being rooted on Android or jailbroken on iOS. Apple has an API called Device Check, and Google has one called Play Integrity. And they exist so an app like this can ask the operating system one blunt question. That question is basically, is this a real, unmodified device in someone's hand, or an emulator automating fraud at scale? And the OS hands back a cryptographically backed answer. This check runs every time you open the app, often before you've even logged in. It's why banking apps flatly refuse to run on rooted phones or inside emulators. No workaround, no exception dialog. From a fraud standpoint, that makes sense, because automated account takeover attacks are often launched from entire farms of emulators running in parallel around the clock. Here's the trade-off worth sitting with though. The same fingerprint data that flags a fraud ring operating out of an emulator farm is, structurally, the same kind of data an advertising SDK wants for attributions. The bank isn't necessarily selling that data set to anyone. But the signal exists in reusable form. And once data exists in reusable form inside a company, different teams find uses for it that have nothing to do with why it was collected in the first place. Now walk through the permissions you already tapped allow on, because each usually has a legible reason even if the app never explains it. Camera access is there for check deposit, where you photograph a physical check, and for identity verification during onboarding, where you photograph a government ID for what's usually called a Know Your Customer check. Contacts access is almost always there for peer-to-peer transfers, so the app can suggest sending money to a name in your address book instead of typing out an account number by hand. Location gets used to cross-reference a card swipe or app login against where your phone is physically sitting at that moment. A purchase happening in a city where your phone clearly isn't present is one of the oldest, most reliable fraud signals in the industry, and it catches a meaningful amount of card cloning and stolen card use. SMS, read access, more common on Android before Google tightened that permission category, let the app autofill a one-time passcode instead of making you switch apps to copy a 6-digit code of a text. So the justification behind each of these is real. The actual problem is granularity. Apple's App Tracking Transparency prompt and Android's runtime permission model both give you exactly one binary choice, allow or deny, with no way to say use my location only to verify this login versus use my location to feed a marketing dashboard. Some banking apps ask for always allow on location rather than only while using the app, a bigger grant than fraud detection requires, since a fraud check only needs your location at the moment of a transaction, not continuously. Here's the layer almost nobody has heard of, and it doesn't show up on your permission screen at all, not even as a line item. A lot of banking apps, especially ones from bigger institutions with real security budgets, continuously sample how you physically interact with the screen while the app is open. Your typing rhythm, how hard and where you tap, your scroll speed, and how you hold the phone measured through the accelerometer and gyroscope already switched on for basic screen orientation. This is called behavioral biometrics, and it works surprisingly well because your typing cadence and the natural tremor in your hand are remarkably consistent session to session and hard for someone else to replicate even after they've stolen your password. The app quietly builds a baseline of how this person holds and types on this phone and flags any session that deviates from it, sometimes triggering a step-up authentication challenge without telling you why that extra prompt appeared. Functionally, this behaves more like a lock than like ad surveillance. It exists to catch someone else using your stolen credentials, not to build a profile of you for targeting. But it's still continuous data collection running the whole time the app sits open, using sensors you never explicitly granted permission for. Because motion sensors on both major mobile operating systems don't require the same prompt that camera or location access does. It just runs quietly in the background, and there's no toggle in your settings that turns it off. Semangam, this is where the fraud prevention justification starts wearing thin. Almost every banking app is built on a stack of third-party software development kits sitting underneath the bank's own code. There's crash reporting, so engineers know the moment the app breaks on someone's device. There's analytics, so the product team knows which screens people actually use. And sometimes there's marketing attribution tooling, which exists to measure whether a specific ad campaign led someone to download and open the app. These third-party SDKs run inside the app with essentially the same access the app itself has unless the developer sandboxes them off. And most consumer apps, banking included, don't bother doing that carefully. A crash reporting SDK has no legitimate need to see your transaction history, but is technically capable of seeing whatever the surrounding app process can see if it hasn't been carefully scoped. This isn't your bank secretly spying on you. It's closer to modern app development, leaning on outside vendors, each a separate destination for whatever data flows past it. The bank's own privacy policy covers what the bank does with your data, in broad legal language. It rarely gives you a clear, itemized list of every SDK vendor bundled into the specific build of the app installed on your phone right now. And that vendor list changes between app versions without anyone notifying you it changed. So even a careful reader working through the policy is reading a document already somewhat behind what's shipping. One more piece worth understanding here. Most banking apps use something called certificate pinning, a technique where the app only trusts one hard-coded certificate for talking to its own servers, rather than any certificate your device considers generally valid. This is a genuinely good security practice, no caveats needed. It stops an entire class of attack where someone intercepts your connection using a fraudulent certificate, including attacks that would otherwise work over compromised public Wi-Fi at a coffee shop or airport lounge. The side effect is that pinning also makes it harder for you to inspect what your banking app is sending over the network, which happens to be the exact technique researchers use to audit apps for this kind of quiet collection. Pinning isn't there to hide anything from you specifically. That's not why banks implement it. But it does mean verifying what your banking app transmits and who it sends that data onto isn't something you can casually check the way you'd point a tool at a website in a browser. It's tempting to pick a side here. Either this is all necessary security, or this is all surveillance capitalism wearing a fraud prevention badge. Neither framing survives contact with how these systems actually get built inside a real company. Fraud teams and growth or marketing teams inside the same bank frequently share infrastructure, because building two separate data pipelines for the same signal is expensive and slow, and a device fingerprint or an app open event is useful to both teams at once. The honest description is that the same signal often serves two masters, and the ratio between them is never disclosed. So what's reasonable to do about any of this? There's no setting that makes a banking app collect nothing, and that shouldn't be the goal. since a chunk of this collection is what keeps a stranger from draining your account the moment they get hold of your password. A few things are still worth doing. Review your permissions again after setup, not just during onboarding. On both iOS and Android, you can downgrade location for your banking app from always to only while using the app, which limits collection to moments you're actually interacting with your account. Keep the app itself and your phone's operating system updated regularly. A meaningful share of what banking apps check for, root and jailbreak detection especially, exists to catch outdated or tampered environments, and staying current reduces the odds of a false flag against your own legitimate account. And don't assume a VPN or a privacy-focused browser changes anything here, because it doesn't. Banking apps run their own encrypted pinned connections regardless of network, and the behavior or device-level collection we walk through happens right there on the device, not in transit. No single tool sits between you and this kind of collection, because it's built into how the app functions, not into the network path it runs over. If one specific data flow bothers you, your bank's privacy policy remains the real authoritative source on what they do with what they collect, and it's worth reading the section on service providers or third parties rather than skimming the friendly summary at the top. None of this is about hiding from your own bank. They need a reasonable amount of your data to serve you properly and to make good on fraud protection promises that benefit you when something goes wrong. The more useful question isn't how do I stop this app from collecting anything at all, because that question doesn't have a workable answer. It's which of these specific requests are doing something for me right now, and which are just along for the ride. And that's a question you can work through, permission by permission, on your own phone. If you want more of this, I put out 2 tests and step-by-step guides that say plainly what a thing actually protects you from, and just as importantly, what it doesn't. The full guides and 2 tests are up at theprivacywire.com, so go take a look and subscribe if you want the next one when it drops.